Okay, ladies and gentlemen, I'm going to run through a few problems here with you. Start with number 36. Number 36 asks you to figure out the number of minutes in a week. So using the same format that we talked about in the video that you saw prior to this, you'll start with what you know over here, 1 week. And what you want to find out goes over here, minutes. But the problem is, with minutes, we don't know how many weeks or minutes are in a week. So we're going to have to do this in multiple steps. First off, we know how many days are in a week. We know that there are, in a week, we know how many days there are. Now you might remember that to do these types of problems, what you put down here has to cancel what's up there. What you're looking for is at the top. I know that there are 7 days in 1 week. These two things have to equal each other. Now weeks can be canceled, and I'm 1 times 7 divided by 1 is obviously 7 days. So my next step then is to start with 7 days, and it's over 1. Change that into something that I know. I know I put days down here. What do I know about days? I'm trying to go to minutes. I know how many hours are in a day. I still don't know how many minutes are in a day. So I'll put hours at the top, and then I'll write down how many hours there are per day. 7 times 24. Need a calculator now. 7 times 24. 168 hours. Next step, take that 168 hours and multiply it by a conversion factor. That's going to allow me to change hours into something that I know. I know how many minutes are in an hour. And remember, our ultimate goal was to find minutes. So this is going to be good for me because I know there are 60 minutes in 1 hour. So if I take 168 times 60, I get 10080 minutes. Hours cancels, and I have my answer there, 10,080 minutes. Now, for some people, this can become a multi-step problem. So you might say, I know I have 1 week, and I want to change it into minutes. But in my first step, so if I put minutes all the way over here, you can say, I know in 1 week there are 7 days. And then I can put days down here and hours up here. And then I can put hours down here and minutes up here because I know these relationships. 1 day, 24 hours, 1 hour, 60 minutes. Weeks divided by weeks is no weeks, right? Days divided by days, hours divided by hours, they all cancel each other out. So 1 times 7 times 24 times 60, still 10,080 minutes. Okay, let's try number 37. You may want to stop and try it on your own before I do it for you, but here we go. We're starting with a 40-hour work week. In other words, 40 hours. That's how many hours you work if you work 5 8-hour days, and that's why they call it a 40-hour work week. Now, the next thing you want to do is convert those hours into seconds. We don't know how many hours are in a second, but we do know how many hours and minutes are the same. So that's going to give me minutes. I put 60 minutes per hour. 40 times 60, 2,400 minutes is the same as 40 hours. Okay? So then I take my 2,400 minutes. Since my ultimate goal is to find seconds, I know there are so many seconds in a minute. This is going to give me seconds. 1 minute, 60 seconds. So 2,400 times 60, 144,000. Okay. Minutes cancel minutes, I'm left with seconds. If I wanted to do this in one step, in one line, it'd be 40 hours times, I'd have to have two conversion factors to get me all the way to seconds. And I would put hours down here, hours and minutes on top. I know there are 60 minutes in 1 hour. That would get rid of hours. And then to change minutes, I'd have to put minutes in the denominator, same match there, and seconds in the numerator. Minutes cancel. So 40, and I could put this over 1. You can see I've kind of stopped doing that because it's just an extra step you don't really need to do. 40 times 60 times 60, still 144,000 seconds. All right. Let's take a look at number 38. Number 38 is a problem where they give you the relationship inside of the problem. As you read it, you can see, so I'm going to write number 38 up here. You can see in the reading it tells you that there are each student needs 8.5 centimeters of magnesium. Okay, so that's a equal amount that I'm going to have to use as a conversion factor later. They ask you if you have 570 centimeters of magnesium, how many students or how many labs could be completed? How many students could complete the lab? So this creates a conversion factor where I take that equal relationship, 1 student per centimeter of magnesium. 1 student goes here, centimeters of magnesium, 8.5. So this is a simple division problem. You probably could have figured this out in your head, but I'm showing you this method now so that you can use it for things that don't seem so easy to figure out in the future when we start working with units that are unfamiliar. So these units that are familiar should be simple for us. Centimeters cancels. I take 570 times 1, divide by 8.5, or 570 divided by 8.5. That's 67.058 students. Well, we know I can't go more than 67 students since students don't come in decimal places. So I'm going to leave the 67.05. I'm going to leave that off and just go with 67 students. All right, number 39. For 39, you are given that for every 1 degree Celsius change, and I'm going to use a triangle to represent change, we have a 1.8 degree Fahrenheit change. So the change is important there. So I'm going to then move over to what was given in the problem. They said you're starting with a 48 degrees Celsius temperature change, and they want to know how much change was that. So I'm going to simplify this by leaving the triangles off. I'll put my degrees Celsius in the bottom, degrees Fahrenheit in the top. That's going to cancel degrees Celsius and give me degrees Fahrenheit. So I know the relationship. It's right there, 1 to 1.8. One of the things I oftentimes tell students is write your units in first, then go back and write your numbers in. A lot of people accidentally flip these things over and creates problems for them. So this answer is 48 times 1.8. degrees Celsius are canceled, and I'm left with 86.4 degrees Fahrenheit. All right, and that takes us to number 40. You should definitely stop and try number 40 by yourself. Set it up, see how it looks before you have me do this with you. All right, for number 40, we are told that 1 atom of gold is equal to 3.271 times 10 to the negative 22nd grams of gold. All right, so that's my equal relationship, my ratio that I'm going to use later. We are told we're given 5 grams of gold, and we are asked how many atoms is that? Okay, so I know I have one relationship, one conversion factor is all I need. I'll put grams of gold in the bottom, atoms of gold at the top. I'm using AU to signify gold. And then I write in my relationship. 1 gram goes on the bottom. Sorry, big mistake there. That's why you write the words in first so you don't do these mistakes. 1 atom of gold. So now I can see the 1 goes with the atom. And the 3.271 times 10 to the negative 22nd grams goes in the denominator. Grams are going to cancel. I'm going to be left with atoms. I need more space to write that answer. I'm pretty sure it's going to be a scientific notation. So, for those of you guys who don't remember, I'm going to show this process one more time. I'm going to enter 5, and I'm going to go times 1, then divide by, and I'm not going to do them times 1 because it doesn't change the value. 3.2 second function EE negative 22. So that says 5 divided by 3.2. Oh, I should back up and be more precise. 3.271 times 10 to the negative 22nd equals 1.5285845 times 10 to the positive 22nd. So I have to decide how many significant figures. 1, 2, 3, 4 significant figures, 1 significant figure. So I could round that to 2, or I could write my answer as that probably is the best way to do it. 2 times 10 to the 22nd atoms of AU. Now that's a lot of atoms because 22 zeros is a lot of zeros. All right, so that's how to set these problems up and solve them. If you weren't here in class, stop in, ask questions if you have any.